This will be for the con assignment, dependent and independent events. There are 150 students in an 11th grade high school class. There are 45 students in the soccer team and 35 students in the basketball team. Out of these students, there are 20 who play on both teams. Let A be the event that student in the class plays soccer, B the student plays basketball. All right, so we're going to answer the following questions. All right, so soccer, they said, is event A, and student plays basketball is event B. What is the probability that the student plays soccer? It said there's 45 students in the soccer team, all right, and the total number of students in the 11th grade is 150, okay? So for soccer, it's going to be 45 out of 150. I might as well just type it in the box. So in the box, you just type 45/150. All right. And now, let me see. For the probability that the student plays basketball, okay, there are 35 students in the basketball team, and that's out of a total of 150. So in the box, it's going to be 35 over 150. 35/150. All right. And here we have, let me see. What is the probability, A and B? The student plays soccer and basketball. Okay. Well, it says right here, there are 20 who play on both teams. Okay. 20 who play on both. So that's going to be 20 out of 150. All right, so click in the box, 20/150. All right. And what is the probability of A given B? Probability that the student plays soccer given that he or she plays basketball. Okay, you need to use the conditional probability formula for this. If you recall the conditional probability formula, probability of A given B equals the probability of A and B divided by the probability of the given one, which is B. Okay, if you don't know that formula, please write it down. So probability of A given B, what we're looking to find here. All right. Probability of A and B, we said it right here. It was 20 out of 150. It was 20 over 150. And that whole thing is divided by the probability of B. Okay, we said the probability of B was 35 out of 150. Okay, remember when you divide fractions, you invert the denominator and multiply. I think you guys learned it as keep, change, flip. Okay, 20 over 150 divided by 35 over 150. Okay, you keep the numerator, so that's 20 over 150. You change division to multiplication, and you flip the denominator. So 35 over 150, you take the reciprocal. It's going to be 150 over 35. Okay? And multiplying these fractions, 150 over 150 cancels. All right? Let me see, you might not have to reduce this. Let me try it as 20 over 35. If they don't take it, I will reduce that fraction. Okay? So this is going to be 20 over 35. All right? And they're asking finally, is probability of A given B equal to the probability of A. And the reason they're asking that, okay, and again, you want to write this down. Write this down, please. If probability of A given B equals the probability of A, then the events are independent. Okay? And that makes sense, because here we're asking probability of A given B. If the given B doesn't matter, then the probability of A given B should be the same as just the probability of A. Because if the events are independent, the given B shouldn't even matter. All right? So if this question is a yes, if this is a yes, then A and B are independent. All right, well, let's see. For A given B, we got 20 out of 35. All right, and for probability of A, we got 45 out of 150. I don't think those are equivalent. Let me see. Does 20 over 35 equal 45 over 150? Definitely not, right? You can check by cross multiplying, or you can just do on the calculator 20 divided by 35, and I get a 0.57. And for 45 over 150, I get a 0.3. So those are definitely not equal. So the answer is no, they are not independent, because probability of A given B does not equal probability of A. So that's answer B. Okay, but it says choose all answers that apply, so let's make sure. Answer B, it's definitely not a yes, and answer D is correct. A and B are not independent, okay? And the reason that's true is because A given B does not equal A. Okay, so you see I got it correct. They did not make me reduce the fractions any further. All right. Okay, Chloe has 10 books on her bookshelf. 3 have blue covers, 7 have red covers. 2 of the blue books are mystery, 1 is fantasy. 5 of the red are mystery, 2 are fantasy. She closes her eyes and randomly selects a book. Let A be the event. She selects red, B be the event. The book is mystery. Which of the following statements are true? Okay, let me see here. So there's more than one way to do this one, okay? But basically, we have to figure out if the events are dependent or independent, all right? And there's a simple formula that we've done before to prove that. If the events are independent, the probability of A and B equals the probability of A times the probability of B, okay? So if the events are independent, the probability of both, you just multiply the individual probabilities, all right? So let's try that. All right, so we have all our information here. And they said event A is that she selects a red book. And event B is a mystery novel. So let's see. The probability of A that she gets a red book, well, let's see. There's 10 books on the shelf, so the total is 10. That goes in the denominator. And 7 of them have red covers, so there's 7 red books. All right, so the probability of getting a red book is 7 out of 10. For the probability of B, the chance of selecting a mystery novel, let's see. Out of the 10, 2 of the blue books are mystery novels, and 5 of the red books are mystery novels, okay? So 2 plus 5 is 7. There's 7 mystery novels out of 10 books. So the chance of selecting a mystery novel is also 7 out of 10. Okay, it's just a coincidence that they happen to be the same. Now, the probability of A and B, that it's going to be a mystery novel and a red book, let's see. Well, 5 of the red books are mystery novels, okay? So the probability of A and B, since 5 of the reds, 5 books are both red and mystery, that's going to be 5 out of the total, which is 10. All right? So if these events are independent, then the probability of A times the probability of B will equal the probability of A and B. Okay, and we can already see that's not going to be true. All right, so let's multiply probability of A times probability of B. Probability of A is 7 over 10. Probability of B is 7 over 10. 7 times 7 is 49. 10 times 10 is 100. Okay? 49 over 100, that does not equal 5 over 10. Those are not equal. Okay? So this statement is not true. That means the events are not independent. They are dependent. All right? 49 over 100 is 0.49. And 5 over 10 is 0.50. So those are not equal. So this statement is not true. The events are not independent. All right? So let's go to our answers. Okay? We said before, for this to be true, the events have to be independent. We just did that in the last problem. So since we said it's dependent, this is not true. And then in part B, all they did was reverse it. Here they have A given B equals A. Here they have B given A equals B. That's the same thing, basically. Okay? This can't be true because they are not independent. We said they're dependent. All right? And here it says independent. We just said they're not true. D says they're dependent. Yes, we did say that. And for part E, we just proved this is not true. Okay? So the only answer is D, even though it says choose all answers that apply. D is the only one because they're dependent.